Next up, we have Tim Woolery from Advanced Chemical Technologies.
We obviously think silanes are so important, you get it back to back. Welcome for that, you know. And I wanted to thank Ed and Darlene and Zach and the rest of the crew for putting on a great conference. And they work hard all year long. They put 4 of these on, and so thank you guys for doing this. It's a lot of work, and I know we all appreciate it. Silanes, you just heard a lot about the corrosion inhibitor properties. We're gonna go a little bit on it, not quite to the scientific level of that, and talk about applications. So what we're going to talk about is a little bit about what the problems are as far as water and concrete, just a touch on the chemistry, the testing that goes on. I'll go through application techniques, show some videos on that, and then how to write specifications. Writing a good specification is important for what you do. If you don't have a good spec, then the contractors kind of can get away with what they want to get, and then either A, the program doesn't work effectively, you don't think the products work. So we're going to talk about how to write a great spec, and then the cost. Water's the enemy. I mean, let's face it, the de-icing salts, you put the icing salts down, the water gets on there, takes that chlorides down into that rebar, corrodes the rebar, and then freeze-thaw damage. You see this every day. If you've walked from here to the hotel, going out to the right, you'll walk up that sidewalk, and there are pop-outs the whole way to the airport or to the hotel. It's real easy to stop that by using silanes. Easy to use, but that's that freeze-thaw damage that you see. So it's spalling and scaling, cracking. I mean, these are these same problems that you see every day out in the field, ASR. But this is the one that I see the most these days around the country. And this is on the substructures. The decks are sexy. I mean, we like fixing decks. That's what the public drives on. So we really work hard at that. But then when we look underneath these bridges and you start seeing all the substructure corroding, and this can be stopped. But it appears we spend more time on the decks than we do on that substructure. But as I drive around the country, this is what I see everywhere. And it's a problem. The barrier walls, you know, that bottom 6 inches of that barrier walls, they're just getting corroded everywhere. We pile the snow up against it. It sits there for months. It's got the salt in it. Just starts eating it away and corroding it. What do silanes do? Concrete loves water. You put water on concrete, it soaks it up. So silanes turn the concrete from being hydrophilic to hydrophobic. When the water can't soak in there, the de-icing salts can't get in there, the concrete lasts a lot longer. If you've stopped by my booth, this is just sand that's been treated with silane. And that loose sand, and we show this every day at the booth, it reacts with the sand, makes it hydrophobic, and that water droplet will sit there until, if it's at my booth, someone walks by and sticks their finger in it. Want to know how that sits on the top of that sand. Another example of just showing how the water can bead up on concrete that's been treated. You typically don't see a lot of water beading on your bridge decks because they're rough. I mean, when you spray silane on there, it soaks in, it's gone. You don't think it's there, but it's stopping that penetration of water. Just a touch on the chemistry. There's basically about 6 that are out in the market. There's a few others, but they're big, long names. There's really kind of these 6 that are out there. So it's isobutyl, trimethoxy, isobutyl, triethoxy, N-octyl, trimethoxy, isooctyls. They all work. They all do the same thing. There's a little bit difference in the molecule size. The biggest difference is in their dry time. The isobutyls dry faster than any of the other ones. So if you're in a high traffic area where you got to get on that bridge and get off that bridge, then the isobutyls are your choice because they dry so much faster. You can get on that bridge and in 30 minutes, you're off that bridge. It'll take you longer to set up the traffic control than it will for that silane to dry. But they all basically work exactly the same. It's the function of dry time. So when someone walks in and goes, well, mine's a lot better than theirs, or my gallon goes farther, it's just not the case. Okay, so that's when these programs don't really function as well as they should. Solvent-based versus water-based. Everybody has them both. The advantages to the solvents, in Tim's opinion, is they dry much faster. You're not waiting for water to dry. And my personal opinion is that the solvent bases penetrate more deeply into the concrete. And after all, it's penetration that we're wanting in the concrete. The deeper that silane penetrates, the deeper your hydrophobic layer is, the better the silanes will work. They'll last longer, they just perform better. Silanes have been tested since 1977 in this country. The first bridge was done in Oklahoma in 1977, and we have been testing silanes to this day because for some reason we don't think they work. So we keep testing them. Every DOT tests them. Of course, we don't believe our neighbor, right? I mean, North Dakota probably doesn't believe what South Dakota does, right? I mean, you know, it's South Dakota, for gosh sakes. You know, we're not going to believe those guys, right? I mean, Oklahoma doesn't believe what Arkansas does, and Texas certainly doesn't believe what Oklahoma does. So we don't trust each other. That's the value of these meetings, is so we can have these conversations. Because we keep testing the same thing. It's kind of almost the definition of insanity, right? Keep doing the same thing over and over, expecting different results. We keep testing them. I've sent Silane to 2 different universities this year for testing. Purdue has got a great study going on. They've been studying silanes for years over there, and their results are great. By the way, all these tests are on the internet. You can find them. You don't need to keep testing. You know, there's no academia in here, right? Because they'll be going, yeah, we do. We need that grant money. So, I mean, there's just a lot of great studies out there that you can find on the internet. We'll see a study from Oklahoma State in just a second. This is a great study from 1985 by Wisjani Elsner. They took a 40% silane, they did that salt ponding test, 48 weeks of testing, no corrosion on the rebar. But for some reason, we doubt that. These are a lot of the performance tests that you'll see probably on your own specifications. Freeze-thaw studies, moisture absorption, chloride penetration. So these are kind of, and you just, as you look at that, you can see that the performance compared to a control, if you're going to reduce moisture absorption by 90%, you've really given your concrete a lot better chance to survive freeze-thaw damage and de-icing salts. So if you write a spec, these are typically some of those ASTM tests that people put in their specifications. This is a Rylum tube, and this is actually working for once on this screen. You can see the untreated one there, how it's drinking that water. This is a test where you pucky this down, you've treated that block, you pucky that Rylum tube down there, you put water on there, and you measure that amount of water that concrete absorbs. We don't typically do these on bridge decks, but this is what's done in the parking lot industry a lot and on buildings. They'll test the building or the parking garage, they'll test for moisture absorption without a treatment on there, then they'll treat it, then they'll rerun this test a couple weeks later to determine what that is. And they typically measure that in like a 20-minute or 30-minute time frame to see how much moisture it drinks. But you can just see, I mean, you can't see it in the concrete, but that concrete's drinking that water in there. This is a recent study by Oklahoma State University. Walt had this study run on how long do silanes last. I mean, they've been coating bridges in Oklahoma for a long, long time, and so it was a great question. This is also on their internet to break this down. They took 60 bridges, pulled cores from all those bridges, and then they tested them for how much silane or whether there was silane still present in that concrete. In the bridges that were 6 to 12 years old, 100% of those bridges still showed the presence of silane. So when people ask how long does silane last, now there's a study that tells you. Bridges that were 15 years old, 66% of them still showed the presence of silane. Bridges that were 20 years old, 21%. So silanes last a long time. So applications, we're going to talk about that. Surface preparation, sweep the bridge, blow the bridge, wash the bridge, shot blast the bridge. Every state does it differently. In Oklahoma, we shot blast. In Illinois, they just blow the bridges off and sweep them. Some states, New York has a bridge washing and sealing program where they actually wash the bridges. Surface preparation is important because it improves the penetration. If you shot blast that bridge, you're going to get better penetration than if you just sweep the bridge and blow it off. Problems with power washing bridges, now you've got to wait for that water to dry. This is what we do in Oklahoma. This is an example of shot blasting. I'm sure you've seen this. Where's Sarah? Sarah, this is our drone footage that we did, and she showed that presentation on drone footage, and it's pretty cool. And so we did a job where we did drone footage. But you can just see the difference it makes in that concrete when you shot blast. You definitely clean that, And it's not a heavy, it's just a little more than a brush blast, I would say, but it certainly opens up the pores of that concrete and allows that silane to penetrate a lot deeper. Applying it, it can be as easy as, this is a smaller spray bar than what a tree showed. This is a bridge in Arkansas. This has a blue dye in it. You can see how low that spray bar is to the ground. That is good for you, because that means that silane is getting on that concrete without a lot of waste. There's not a lot of blow by, it's not blowing all over the atmosphere. It's getting on there at pretty close to 100% transfer efficiency, and that's what you want. You want that silane from that bucket to get on that concrete. It's really fast. This bridge probably dried in 20 minutes. A truck is a great way to do this also if you can get the spray bar down low enough. You'll see this is a contractor in Illinois. Sorry, Indiana. But this is the trucks that Indiana made. Do you see the difference from where that spray bar is located? See how high that is off the ground? The transfer efficiency of that was not very good. So we were just eating that from the spray because it's as high as the back of the truck. So, there was a lot of waste going on with that truck. It's pretty efficient in the fact that it takes only, one guy to do it. But if you're doing short bridges, it's not how Tim would do it. I really like using the spray bar, especially on these smaller bridges. If you're doing a mile-long bridge, a truck like this works great. Hand spraying, there's a lot of people still hand spray in Illinois. They think it's really super fast, but you can see from the picture that the overspray, it's not all getting on the concrete. And that's what you want. You paid for a gallon, you want that whole gallon on the concrete. You don't need it in the atmosphere. When you're writing a specification, most testing is done with about 11 grams of silane per square foot. Okay, it's an important number. So that is, if it's a 20% silane, then that means it goes down at 60 square feet per gallon. If it's a 40% silane, it needs to go down at 125 square feet per gallon. And if it's 100% silane, it goes down at 300 square feet per gallon. Doesn't matter which one you use if you put the right amount down. You're getting the right amount of silane based on application rate. So if you're writing a spec, write it to those type. Don't just say at the manufacturer's recommended level. Because here's what happens. The manufacturers, us included, will write that spec to say, well, you can put it down from 125 to 400 square feet per gallon. Are you getting what you really want in your program if you write that spec that way? Because what are the contractors, if you're not doing it yourself, what are the contractors going to do? They're going to put it down at 400 square feet per gallon. There's only 128 ounces in a gallon. Nobody's gallon goes farther than the next guy's gallon. If it's 100% silane, everybody's is 100% silane. So if you're writing a spec, make your specs tight on, yep, you can use a 40%, but this is your application rate. That way you get what you pay for, and that way the program works and the silane performs. Let's talk about the cost. If you're using a 20% silane, it goes down, that 60 square feet per gallon gives you that 11 grams of silane per foot. If it costs $15 a gallon, it's 25 cents per square foot. It's not very expensive to put it down for the performance, and we just saw that it lasts up to 10 years from the report from Oklahoma, right? 40% silanes at 125 square feet per gallon, you're down to 16 cents a foot. 100% silanes get it down to 12 cents per square foot. Material cost only. Question should be, well, why does the cost keep getting cheaper? Well, if you're buying a 20% silane, you're paying the manufacturer for solvent at that same price per gallon. And then we've got to repackage it. We have to quality control it. There's just a whole lot more people touching, and you're buying solvent. So you're shipping solvent across the country. That's how those costs go up, because you're buying solvent at that same cost, because it takes more per square foot to get that 11 grams per square foot per gallon. The analogy with paint, if you buy a gallon of white paint and put a gallon of water in it, do you have 2 gallons of paint? Kind of. But do you have to paint the wall twice to get the same amount of coverage? Yes. So that's what you need to think about when you're writing these specifications on silanes. Write them so that you get what you want on that concrete, not what the manufacturer says that square application. Because you can apply them You can spread them thin, but doesn't mean you're going to get the performance out of it that you're really asking for. The math on this, 150 by 38 feet, that's a kind of a standard bridge out in probably rural Oklahoma. If it's $140 a foot, that's an $800,000 bridge deck. It takes 45 gallons of 40% silane, which is what we use in Oklahoma. $912 to protect that bridge deck for 6 to 10 years. If you had a car that was $800,000 and the oil change was $900, would you do it? In a minute. You wouldn't even think about not doing it. But yet we build these bridges and then we don't do the easiest thing you can do for that bridge, which is to spray silane on it. It's just, you know, I know a lot of maintenance people are starting to do it more and more, and it's just a great thing you can do for your bridges, for preservations. So why silanes? They work. They're cost effective. They last for years. Doesn't change the skid resistance, and they can be really super fast dry. In conclusion, silanes have been tested for years. They're still being tested today. It's never too late to start a silane program, even if you already have chlorides in there. If you stop the water, those chlorides can't go anywhere. I mean, it takes that water to resolvate and to get those salts to flow on down to the rebar. So if you can keep the water out, those salts can't go anywhere. Super cost effective. It's easier for the maintenance crews to do it. They last a long time. More than you ever wanted to know about silanes in the last 40 minutes, huh?
Apparently there's always something more to learn about silanes. I was wondering about crack decks. We had a debate at our agency about silane in combination with sealing. And we went, do you do it after or before? And we came to kind of the conclusion that it's beneficial to apply before and then top crack seal. And how does silane treat the root of a crack, so to speak?
Oh, the question is about applying silanes or crack sealers first. Always put the silanes down first. You want that silane down into that crack so that it stops any water or any further freeze-thaw damage, then fix your cracks. If you get the silane down in there and it penetrates into that crack, then when you do crack fill it basically is going to push that even farther into that concrete, studies show. Yeah, it's always silane first, crack fill second, and then you're going to keep the water out. And if it's a good crack filler, then your cracks are fixed for quite a while.
Is there anything you can say about the safety of silanes for the applicators? Any precautions you need to take for the applicators? Okay,
so the question is kind of about PPE, basically PPE for the applicator. They do have VOCs in them, but you're typically outside. So as long as you're outside and not in enclosed condition, there's no need for respirators. I would probably recommend glasses, safety glasses, and if someone's pouring it from one container to another, gloves wouldn't be a problem. But otherwise, there's no abnormal PPE required on the material safety data sheets on any of these. So they're relatively safe. You don't want to drink it. It does work as a pretty good roundup on the edges of the concrete. It will kill some vegetation if you get it on the grass. And you do not want to get it on blacktop. Okay? Do not get it on, because it'll eat up on asphalt.
Hey, Tim, are you aware of any states that apply it to substructures? Is that anybody doing that?
Yes, more and more states are going to substructure. Maine is almost doing all their substructures now. And I think it's more and more. What I would like to see happen is when a bridge inspector or someone goes out to check a bridge, they look over where the expansion joints are, because that's where that corrosion's happening on that substructure. Expansion joints fail, or they're dumping stuff and dumping it right on the end of a pier cap or whatever, and then you see corrosion. I mean, how easy would it be to take a pump up sprayer, look where water's running down there, and just spray it on there and let it just run right down also? And then you stop that from sitting on the top of that. So yeah, more and more states are starting to do substructures. I know Maine is doing it. I think Missouri started doing some of their bridges that way, so I think it's more and more it's happening.
New Hampshire's doing it in the splash zones, wherever that's where you get an awful lot of salt as well.
Right.
I had a question about storage and freezing of either the solvent base or the water.
Question is about storing, what about freezing and for a freeze thaw of just the material itself. If it's a water-based material, it needs to be stored inside out of freezing. The water will freeze. The typical solvent-type silanes, 100% of 40s and 20s, typically, they can be stored outside without any problem. They're basically a solvent, if you will, so they will not freeze. What I would do, though, if you're storing drums outside, is you turn the bungs sideways. So, the bung hole's on the top. turn those drums sideways, put a 2x4 on the ground, set those bung holes parallel with the 2x4 and lean it up on there. That way water, if it gets water on the top of that drum, it drips off opposite of the bung holes. That make sense? So if you're going to store them outside, just put them on a board so water doesn't sit on that lid. You do not want water getting in that silane.
Minnesota's looking at a 20-year look back, and one of the substructures that was treated with silane, it seems like it's trapped moisture also and led to some accelerated corrosion. And so I don't know if you've experienced or heard any studies about the blocking effect of moisture that's already in.
I have not, because all studies show that they're vapor permeable. So it'd be interesting to find out more about that.
Thanks.
I'm done.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.